So we want to pick up something big that we can kind of spend our time working with, okay? And so we want also something to be that is a good fit, that's understandable ideally by the person who's interviewing you, right? Or is going to be a good demonstration, a good fit with what you're building. So there's a video here in this document. I've linked it inside of that. I just put a link on Discord to this link. This is the one coding project idea guaranteed to get you a software development job. This is a really good video. He does a really good job of explaining this, and this is kind of part of where I pulled my inspiration for this from. It's like, oh, you have a great point. Let's do that. So that's what we're going to do. Okay. So that's kind of where this inspiration comes. I would definitely recommend that you watch through that before you get too much into this project. Okay. So, but I want to kind of give you the background. So what we're going to be doing is we're going to be building something called an issue tracker. Sometimes it's also known as a bug tracker. Might be used for support tickets. Might be used for tracking work orders that need to be done at the automotive shop. Okay, this actually can be a lot of different things, but specifically we're going to be talking about, bug tracker in the sense of working with software bugs. Okay, is where we're talking about this. So basically any company that you work with is going to have one of these bug trackers. They're going to have a bug tracker where they keep track of work that needs to be done, which is where we kind of call it an issue, features that need to be built, all sorts of other tasks that need to be done, as well as defects that you found in the software, okay, known as bugs. So we're building an application that can do this. So I pulled a little bit of a blurb here from Zendex, which is a really popular tool for tracking support tickets. All sorts of companies use this. So we're kind of building something that's similar to Zendesk or Jira. In fact, there's a bug tracker over on GitHub, in fact. But there's a bunch of these different things available. So the question is, well, what is an issue tracker? So if I read some of the blurb here, software development is complicated. Even the most highly skilled software engineers in the world write code that has bugs. There's really no such thing as a software release that's free of problems, is a stubborn fact of life that development teams face every day. However, fixing software issues, while challenging, becomes much easier when companies use an issue tracker. So simply put, an issue tracker records issues customers have experienced with a software product, and it enables support agents, engineers, and managers to track those problems until they have been successfully resolved. Right? So it's the entry point where oftentimes it may be a tester on your team, it may be another developer that finds it, maybe a customer that finds it. You add it to the issue tracker, and then you track it until it's fixed. Until you figure out what caused the bug, what caused the issue. You're going to log all that in the issue tracker. You're going to log the changes that have been made to the code. You want to log some of that information as well. Any decisions that you've decided to make to the design or things of that nature, you would track those things. You track what release, what version number did it go into. So say maybe it went to version 3.0.5. You would track that and work its way until, okay, finally it gets released to the customers. You mark it, finally it's done. So the part of the issue tracker is to track that whole process. Okay, that process can get pretty complicated. It looks very different depending on what company you're working with. Okay, so a simplified version would be just here's a name and a description of the bug, right? Or in addition to that, usually you have what are the steps, what are the sequence of things that you need to do to make it happen again. We call that the steps to reproduce it. In there, you generally start to have conversations on the bugs. So those bugs tend to have comments, right? You have discussion threads within a bug. You might have test cases that you need to write. So the tester or developers write those test cases and say, here's what you need to test to make sure that the bug has been fixed, right? So at the end of the day, if the test passes, bug's fixed, test fails, there's still something wrong, we need to go back and work with it. So you got test cases. Other things you need to do is track the history, things that have happened. How has the bug changed? How has it evolved over time? So there's a lot of things that an issue tracker needs to do. Another common thing that needs to fit in there is generally you need to send out emails or notifications or text messages as things occur, as certain events happen, so that people know about what's going on. Okay? That notification piece we're not going to tackle this semester. That's outside the scope, right? So we have this idea of scope, scope of what are we building and what are we not building. Okay, so things in scope, we're going to say, yes, we're building that. If it's out of scope, yep, it might be something, it might be a valued feature, but we're not building that today. Okay, so there's things in scope and there's things out of scope. I'm kind of trying to give you what that scope is, right? And so that's part of what's on this document. Okay, so does everybody kind of have an idea of what I mean now by an issue tracker? Has anybody never seen an issue tracker? Just by a show of hands. Has anybody not seen an issue tracker before? Not familiar with what this is? Well, that's impressive. That's impressive that you've already seen this. Okay, that's good. So, looking through at Lab 2.2, okay? So what we have here on the first page, okay, is you're going to find the overarching requirements for the application that you're going to build this semester. Okay, these are the overarching requirements. And these are written from a customer's perspective, from a user's perspective. This is how I need the system to behave, okay? Because that's typically how we get our requirements. We get them from the user perspective. We don't get them from the developer perspective. You're going to get your requirements, the things you need to do, from the perspective of the user that's going to use your software. Okay? Now, that means that you're going to have to come up with some implementation details, some implementation decisions of how are you going to make it happen. Does that make sense? What technologies are you going to use? How are you going to design that schema? All of those kind of things, right? So I am going to tell you about what technologies we're going to use, right? And I'll give you some pointers in the general direction. But a lot of the technical decisions, I'm going to leave up to you. In some cases, there is definitely like you need to do this and not that. Other cases, like, well, you can do this A or B, and it's fine, right? There are going to be some technical decisions in there where there are multiple valid and multiple correct solutions. Okay? So at the end of the day, you guys are not going to end up with the same program. I think when we did a small version of this over the summer, you saw how different your 5 programs were. They were not at all similar in terms of how they looked to the user, right? You might have had some similarities in there, but the final thing that you produced was very different because you came at the same problem at very different ways. And I would expect that same thing here, right? I'm giving you some common requirements about what it needs to do and how it needs to do it, but the actual implementation is going to look different. Does that make sense? I'm going to expect there's going to be some difference between how your things look. So general application requirements. Let's go through some of these and maybe we can talk about them. Okay, so let's start from the top. So general application requirements when we build this. If you don't have a piece of paper, pull a piece of paper out and take some notes. So far we've talked about how to build the database, right? So what we're dealing with now is just how to design the database. In the end, we're going to work this all the way up to a front end, right? So there are some requirements on this list that don't matter today, okay? There are some requirements on this list that will matter later and eventually, but are not going to influence the design of your database. Does that make sense? Some of them will, some of them will not. But I'm trying to give you an overarching view of where we're going. Does that make sense? I'm trying to give you an end point of where are we going. Okay? So the first thing I say, number one, is that your core entities are bugs and users. What do I mean by that? Yeah, I'm actually telling you straight up there that you should have a bugs collection and you should have a users collection. Whatever schema you come up with must have a bugs collection and must have a users collection. Because that's what this system's about. It's about bugs and users. Okay? Everything else, every other piece of data that you come up with is going to be connected in some way, shape, or form to one or both of those collections. Does that make sense? Every other piece of data that you come up with is going to be connected to bugs or users. I'm not saying there that you're going to have two collections. I'm saying you're going to have at least two collections. There's a bunch of ways to design this out, and it can be anywhere from, say, 2 collections to 8 collections. Keep in mind the design parameters that we talked about anti-patterns, right? So you may want to combine some things together. You may not want to combine some things together, okay? Think about what is bounded and what's not bounded. So I'd strongly recommend you put those cardinality numbers on there. Remember how we said, hey, this is 1 to 20? That will give you some indication about what things should go together and what things should be apart. Okay? So we know we've got bugs, we know we've got users. We know we're going to have those collections. Next thing, number 2. So let's read this off. So I'm going to start passing this around. So Adrian, you read off number 2 for me.
The following information is required for all users: email, password, full name, given name, family name, and role.
Okay. What does that mean?
That's the okay, name. That's the one with view connection.
Okay. Evan.
What do you want to say?
What does that mean? What does requirement number 2 mean?
Oh, it means that minimum within each document.
It has to have.
Users, it has to have those fields.
Yep.
They have to be populated.
They have to be populated. And in terms of the UI, I'm saying that those are required fields.
Sure.
Okay? So that gives you some indication about what data needs to be there. All right, so Parker, grab number 3 and explain to me read number 3 and tell me what we mean there.
Users can log into the system using their email address and password.
Okay.
So basically, like, it's gonna be required to have an email and password to
Yep.
get into the.
So users have to have an email field, and they have to have a password field, right? What else does it tell you? Okay. It also tells you at least 1 or 2 other things about the database. Anybody else know?
You're gonna know the login.
Have to have a login. Well, I'm saying the login is email address, right?
It has to be unique.
Yes. If I'm going to log in with email address and email password, then the email has to be unique, because otherwise, which account do I am I logging in? Right? I immediately know with that the email must be unique. I can't have 2 users with the same email. Okay? I also know that I'm going to need to index the email field, because at the login screen, I need to say, okay, give me the user with this email. Okay? I don't need to index the password field. I just need to index the email field. Okay? So we're learning some stuff from that, right? About what we need to do. Does that kind of make sense? We have to take this from the user's perspective and turn that into what does that mean for our schema? Make sense? So we know how the user is going to use it. We can figure out what does that mean for using the system. Okay. We're at number 4. Michael?
Users can have different roles: developer, business analyst, quality analyst, product manager.
Okay.
I guess that means just like quality users, like with the role. Each user has one of the roles.
Okay. So how would you interpret that? Is there something that means for our schema design?
The title of each user.
Huh?
The title of each user. So
the title of each user, or more correctly, the role of each user, right? we're saying each user has a role, okay? And we're also saying, can it be any role? Can I come up with frog and say my name is, my role is frog? Can my role be helicopter? My role cannot be helicopter. It's not on the list, right? So these are the roles that are available, and I can't pick something that's not on the list, right? So we're also saying we're constrained to these are the roles that you can choose. You can't choose another role. Okay? You can choose one of the roles on the list, but you can't choose something that's not on the list. Make sense?
Can the user like not have a role?
No. It can. Every user must have a role.
Does each user can only have one role?
Yes. That's what I'm gonna. Let's limit it to that. There are some cases where you may want users to have multiple roles. For this, let's say users only have one role, one and only role. Keep it simple. What were you gonna say, Evan?
Like Discord, users of multiple roles.
Yeah, that's true on Discord. You can have multiple roles. So number 5, we're down to Brandon.
Any user can create a bug, and all bugs must contain the following information: title, description, steps to reproduce, author of the bug, date, time creation.
Okay. So what does that mean? What can we read out?
Just like those are just like the attributes of a bug, like
Okay.
those are things that make a bug a bug.
Right. So we know that bugs now have to have a title, description, steps to reproduce, an author, and a date, right? We've been given some information about the fields that the bugs need to have. That's one thing, right? Do we know anything else? You said that they are required?
Yeah.
Okay. So we know those are required. Is there anything else we can pull out of this information?
Data types.
What?
They're data types.
Yeah, we know what data types they are. So specifically, I told you on steps to reproduce, what data type did I tell you it needs?
String.
A string. Because that could be interpreted as a list of steps, but I'm saying keep it as a string. The reason I'm asking you to keep it as a string is because then from the UI perspective, you can have the UI for that to just be a text area. Otherwise, you would have to make a much more complicated UI to represent that, and it turns out it's not really that important to keep them as separate as a list. Okay? So that's one of the things we're saying. Is there anything else that we can read from number 5?
Any user can create a bug.
Okay, any user. So that means regardless of your role, you can create a bug. Make sense? That's important, right? I'm not saying, go for it.
I have a question.
Yep.
Is this application only accessible inside the workplace, or is this, you're talking about bug creation? Is this
Yep.
something that an actual user of the actual application, the end user, are they submitting bugs as well?
So that's a good question. That is a good question. And in some support ticket systems, that is actually the case. Customers can submit bugs. In the list of roles, did I list customer?
No.
Okay, so customers are not a role in this system. There are some systems where that is the case, where an outside user could submit this. Yes, this is internal. And in fact, you won't be able to access the system at all if you're not already logged in. Yes, I am saying you do have to be logged in, and you do have to be one of those roles to use the system and create it. Okay? Chase, we're down to number 6.
Didn't users can edit the bugs that they created?
Okay. What does that mean?
So I guess that means that when somebody creates a bug, they need to be able to be assigned that.
Okay. Not really. I wouldn't say not really.
To me, this means that bugs now need to have an additional field that says who created it and who's last edited it.
Yes. Yeah, we do need to know, would like to know who was the person that created it originally, as well as who edited it last, from a tracking perspective. We do want both of those things. Because we do need to know, the author of the bug. Well, actually, the author of the bug, isn't that the person who created it? Mm-hmm. Okay.
Yeah.
So we've actually kind of captured that, right? So we've captured the author of the bug is always able to edit it. Yes.
So you said all the bugs are edited, and like anybody edit what they want, you can create it.
Any user can edit the bugs that they've created. Okay, so what I mean by that is if you are the author, then you can edit it. That doesn't immediately get anybody access to it. Just it gives the author access to it. Does that make sense? So if you're not the author, you may not be able to edit it. Okay? If you're not the author, you may or may not be able to edit the bug. But if you are the author, you can definitely edit the bug. Make sense? The reverse is not necessarily true. So that's why we need to look at number 7. So David, number 7.
Bugs can be assigned to developers, business analysts, and quality analysts.
Okay.
So product managers and technical managers can't assign bugs.
Correct.
We obviously have to link users to bugs and how to show which type of use assigned to it.
Okay. Does it tell us anything about the schema? Because I argue that this tells us something more about the schema.
It should be an array.
What do you mean it should be an array?
Because you can assign it to including one or including all the others.
No, I'm saying that this can still only be assigned to one person.
Oh, okay.
But the person it's assigned to is going to be one of those roles.
Okay, and said again, I thought it was inclusive.
Yeah. What were you saying, Michael? You have your hand up? Okay. So I'm still assuming that it's assigned to one user. Okay. But notice now we have a distinction between the author of the bug and who the bug is assigned to. Who the bug is assigned to and who created the bug are not necessarily the same person. Right? So if they're not the same person, then does that mean something for our schema? Does that mean something for our schema?
Bugs can have to show who's assigned to.
Right. So we need to track the user it's assigned to as well as the user who created it, the author of it. Okay. So we need to track those as fields. We need to track who's it assigned to and who created it. And so going to number 8, I'm going to jump over to Josh. Number 8.
These users can modify the bugs that they are assigned to, but not the bugs that they did not create or are not assigned to.
Okay, what does that mean?
So basically, they just can't, if you're not the one who created the bug, you can't do it.
Right. If you didn't create it or you're not assigned to it, you can't do anything with it. Right? If you're either of those two people, then you are free to edit the bug. Right? So at any given time, there's a maximum of 2 people, 2 users that are allowed to edit bugs, to edit that bug. Cool. Does that say anything about the schema that we haven't already learned? Short answer, no. It says something about how we'll access the data, and it says something about security, which we'll have to come back to later, but it doesn't say anything today. Cool? Because we've already tracked who created it and who assigned it. Okay. Aaron, number 9.
All edits must be tracked with the date and time the change is made. The user who made the change and publish change.
Okay. Number 9 is a really big requirement. Okay. Don't miss number 9. Definitely highlight that one on your list and to come back to. That is going to require a bit of thinking about how you're going to design the schema. Okay. Notice what it says. It says every edit has to be tracked.
Does that mean every edit?
Huh?
Just that an edit occurs, or the?
So how do we edit a thing with Mongo or with SQL? There's an update, right? So if an update would be an edit. Anytime I run an update, I need to track how I just updated. Does that make sense? All updates to the bug have to be tracked. Doesn't matter what caused the update, doesn't matter how the update happened, doesn't matter who made the update, every update has to be tracked. Does that make sense? Does that answer your question?
I want to
Okay.
know is if you want us to track the content of the update or when the update occurred.
What does it say? So it says all edits must be tracked with the date and time the change was made, who made the change, and what was changed.
Okay, that's all.
So the answer is all of the above, right? I need to know who made the change, when did they make the change, and what did they change. Okay? All of that information. This number 9 is a hard one. I will say that right now. Number 9 is a hard one. It's one of the ones we didn't do this summer. We did a small version of this. I didn't ask you to do number 9. Okay? Number 9 is in fact one that kind of keep that one on the back burner. We'll come back to that one kind of thing. But that's an important thing. For a lot of systems, you need to be able to track all the edits that have been made. In fact, the system that I worked on with Biomed, that was actually one of our requirements. We had to track every single thing that had been done. From a security standpoint, from an auditing perspective, you needed to do that. Okay. That's something that, because it affects every update, tends to affect a good percentage of your code. Okay. If in order to satisfy number 9, you're going to find yourself writing a good amount of code just to do that. Okay? All right. So, Cody, number 10.
Anyone can add comments to the bug regardless of who created it or who is assigned to it. These comments must include the author, date, and time of creation. Bug can have multiple comments.
Okay. So what have we learned?
So essentially there's like really strict criteria on who can create the bug and edit it when it comes to comments.
It's completely free, right? Anybody, it's a complete free-for-all when it comes to comments. Anybody can write a comment. But now we have something new, right? A comment is a completely new thing, right? We haven't talked about comments up to this point, right? So you have to figure out where you're going to fit comments into your diagram. Make sense? What else have we learned about comments?
Potential for seeing the document.
Yep, that's one thing you have to worry about. Are you creating a massive array sort of situation?
They also have author, date, time of creation.
Okay. So we know a little bit about the content of that comment, right? So we know that comment has to include who wrote it, when did they write it, when did they post it, the date and time of that posting. We also need to know the actual, one thing that's not mentioned here, we need to know the text of that comment, right? Because comments have text, right? So it gives you some, like, hey, here's another piece of data that I need to store somewhere, right? I didn't tell you where to store it. There's actually at least 2 choices to do that. But I need to store it somewhere in the database. Cool? Huh? I didn't say where to store it. I didn't say what collection to put it into. But I said it needs to be somewhere in the database. Okay? And so there's at least 2 different ways to do that. There's at least 2 different ways to do that. And there's not one correct answer, in fact, to how to do this. Okay? There's multiple correct answers. Okay. Number 11 says comments cannot be edited. Short answer there, doesn't affect our database diagram. So, number 12, Danny. Okay, so what do we get out of that? Yep, so every bug has some sort of current classification, okay? And we know it can be one of those values, okay? And here it says the business analysts are the ones that are doing that. That will matter when we get to the application, but the fact that it's a business analyst doesn't really matter as far as designing the database. Does that make sense? So there's some of these requirements like this where part of the requirement matters now and part of it will matter later. Okay? And so that's part of your designing and part of you being a developer is looking through these requirements from the user's perspective and figuring out how to translate that and parse that and figure out what are the pieces that I need today and what are the pieces I need tomorrow. Okay? But they're going to be intermingled with this. Michael, we're on number 13. I'm missing a word. Can add. Okay. So what does that mean? They can add test cases.
They can make the case also well. They can say test, fail,
Uh-huh. So is that a new thing? Right? So we got kind of a new sort of document or subdocument for test cases. We know a little bit about what needs to go into those test cases, right? So we need like the steps of the test cases, right? What is the test? How do you actually run the test case? Things like that. We also need a way to mark them either pass or fail, right? So we have some data we need to store. The test case itself, it passed or failed. One thing that I don't think I marked on there, but I do want you to track, also track who created the test case. Who created the test case and who last updated it. You want to know who created the test case and who last updated it. Similarly with the number 12, I want to know who assigned that classification. I want to know what user assigned that classification.
Which quality analyst?
Which quality analyst for number 13, which business analyst for number 12. Right, so I need to know who chose the classification and who created the test cases. It's also worth noting that as it says here at the end of 13, bugs can have multiple test cases. They can have more than one test case. Because as you have more complicated bugs, one test case may not be enough. Okay? Which if there's multiple, that tells me there is a one-to-many relationship, right? We know there's a one-to-many relationship there. We were down to Don. So Don, we're on number 14.
Developers can track the amount of time that they spend on the bug.
Mm-hmm.
Developers can submit those hours multiple times.
Okay. So what do we know?
So each bug would have a log of the amount of time they spent.
Right.
So a lot of times the developer spent working on it.
Yep. And think that developer, like there could be multiple developers on the bug, right? It could be one developer's working on it, they hand it off to another person, they work on it, hand it off to another person. So even though there's only ever one person assigned, it could actually be multiple people doing the work. Cool? So you also kind of want to track who's putting in that time. But we're tracking the time in what unit?
That will be hours.
Okay, right, so that's important. We're tracking the time in hours. We're not tracking milliseconds, we're not tracking down to the minute. We're saying, hey, I spent 3 hours on it. Because that's about the granularity that you really can get out of work and expect, right? Okay, and we also see what's the second part. It says developers can submit hours multiple times. What does that mean? Does it mean something for our database?
It should be an array.
Yeah, it means it's array. Because I can submit hours today, and then I can submit hours tomorrow, and I can submit the hours the day after that. Right? So that same developer can submit hours multiple times. And it needs to not replace like the previous submission. Does that make sense? So I'm not updating the hours ever, basically. I'm submitting them and submitting more and submitting more, right? So every time I submit hours, I'm creating a new record, a new thing there. Okay, so winding back around, Adrian, we're on number 15, I think.
Developers can know what version of the software. Wait, developers can know what version of the software the fix will be released in, and when the fix was made to the code.
Okay. So how does that change our schema? How does that change our schema? Anybody. How does that affect our schema?
I have to have a field for the version for the bug.
Okay, yep. So on the bug, I need to know what version the fix is going into. I know that this version is not going to be set initially. This is an optional field. I'm not going to know it at the beginning. I might know what version the bug was detected in. Maybe it was found in version 1.0, but it might not be fixed until version 2.0. So this is the version that was fixed in. Okay. What else? Is there another field I need in there?
When the fix is made?
Yeah, when. So I need to know when the fix was made. When was the software corrected to fix the bug? Right? When was the update? So like it was made on, I could say in there, maybe it was made on September 8th, 2021 at 3:30, right? So that would tell me when the fix was made. So you know when the fix was made and what version it would be released. Down to Evan, number 16.
Business analysts disclose bugs when they are released to customers, but all of the previous information must be retained indefinitely.
Okay. What do we know? There's at least two things that we are going to learn from this.
We learned some limitations of when bugs can be finalized. And that they're never deleted.
Yeah. So we're never going to delete bugs. There should be no way in your system to delete a bug.
Are we talking strictly the back end? Because you can always delete something back end. Or are we talking front end?
We're talking about front end. Yeah, we're talking about front end. Yeah, in theory, if you have access to the database, then you can run like db.bugs.delete, right? Okay. We don't have a way to block that, but we can block it from the front, right? So there's no way in the front end to delete a bug. You can close a bug, which basically makes it get hidden, but it will never be blocked, okay? Closing a bug does not delete the bug, okay? Now, to track that the bugs are closed, right, we have to know whether a bug is open or whether it's closed, right? So does that mean something about our schema?
No field.
Right, we need a field for
active or inactive.
Yeah, open or closed, active, that's fine, right? Active and inactive, right? So I need to know true or false. Cool? Okay. So that gives you a lot of details about how you need to build out the schema, right? Does that make sense? A lot of those details, there's a lot of things in there that tell you about, I need this piece of data, I need this piece of data. Remember though that you've got number 9, where everything you do has to be tracked, right? I have to be able to come back later and say, who made that change and when did they make that change? So that includes 10 through 16. That includes everything 10 through 16. You need to know who did it and when did they do it.
So is having like a closed bug, is that separate from the classification?
Yes. Yeah, so closed and classification are not the same field. I've gone back and forth between that as far as talking about status, and I'm gonna separate that. So closed is a separate flag than the classification. Okay. Cool. And so you kind of got some ideas. So you kind of, I think, hopefully you've taken some notes so you kind of understand what you need to build. You've seen that some of those requirements, there's a lot of pieces in there that will come back later when we're talking about permissions and authorization and authentication, but there's a lot of things that don't necessarily apply today, but will apply on the line. Okay? So looking at what you need to do for this lab assignment. Okay? So the lab assignment has, I believe, 5 parts. The first part is you're going to create an ERD. Okay? You use Schema, create an ERD. I showed you how I did that for the courses database. You can kind of see how I followed that with the documents and the sub-documents. And we did that previously with MySQL. So you're going to make that ERD. You're going to then take it and implement it using the shell and kind of working through that. You're going to end up producing some JSON files. Namely, for every collection that you have, I want this as that. I'll actually also, you can do this way, or you can give it to me as a text, a TXT file. I'm okay with that as well. You can either give it to me either way. Either as JSON files, or you can give it to me as a TXT type script that we did for the previous thing. Okay? You're also in that script. You want to look at indexes. So you saw the script I had included some indexes that I added to my collections. So for instance, your bugs collections and your users collections are going to need some indexes. I expect to see those in there. Next part 3, is there are some queries that I want you to write. Okay? There's some queries I want you to write. I guess some of these do require aggregate pipelines, so I'm going to need to talk about that sooner than later. So you're going to go through these, write a query for each of these. More than likely, some of these queries will realize that you're missing something in your schema. It's very likely that somewhere in here, when you're writing these queries out, you're probably going to find out that something's missing from your schema, or your schema is maybe not ideal to run those queries. Make sense? In fact, maybe if you need an aggregation pipeline, maybe it's worth going at that point and looking back and saying, is there a way I can design this so I don't need one? Like, if I need lookup, well, maybe I can design my database in a way I don't need lookup. Does that make sense? So what you do here with the queries is probably going to make some changes to what you do with the schemas. Okay? At that point, you want to update your previous things, right? If this makes a change, then go back to your ERD, make some updates there, make some updates to your script. Okay? There's going to be some back and forth. That's fine. Number 4, kind of like we've done previously, right? So we queried the data. We're going to manipulate the data. So there's some CRUD statements I want you to write. Okay? Last step. Update your database design. Last piece of this is I literally am putting points in here to get it back in sync. Because my expectation is as you do 3 and 4, as you do queries and you do manipulations, you're going to find out that things don't quite work the way you expected. That you need to go back to the drawing board and change the schema a little bit. So what I'm expecting you to do is go back to that, look at your JSON files, look at your ERD, look at your index scripts, update that before you turn it in. Make sense? So when I'm looking here and I say -5 points for inconsistency, that's out of the 20 points. Right? If it's all consistent, you're all good. But everything I find where this does not agree with that is going to be something where you're not going to get those points. Cool? Because again, you're going to make changes as you go along. So the part of the trick is keeping those in sync as you make changes in your design. Okay? Questions? It means things like if you need to add an email field later and you forgot the email field, go update everything. Because if something says you have an email field and the other thing says you don't have an email field, that would be inconsistent. Okay. If something says the name of this column is course ID and the other thing that says it's just course, that would be an inconsistency. So it would be inconsistency in name, capitalization, data type, those kind of things.